All right, we have one more of these ideal gas laws. This is Avogadro's law. And if you remember Avogadro, he's the guy that came up with the whole concept of the mole. So N in this formula is the number of molecules or the number of moles that are present in the gas. So this formula is going to do that. In fact, Avogadro's law is the comparison of volume to moles. And because they're on opposite sides of the equation, we know that they're either both going to increase or both going to decrease. So as volume increases, moles will increase. Or as volume decreases, moles will decrease. Same thing. Let's see. So I'm going to draw you a little picture. And here's a balloon, of course. And this balloon has, I don't know, 2, 3, 4, 5, 6, 7 particles flying around, 7 molecules, whatever you want to say. So clearly, if we make the balloon bigger, that's going to increase the volume. And if the volume is increased, guess what? We can fit more moles, more molecules flying around. 6, 8, 9. Okay, so the more the volume, the more molecules, the more moles that can fit in there. This rule's kind of obvious, and I would say of the 3 rules, it's the easiest. Let's figure out how we get the formula. If we have PV equals nRT, we need to isolate the V and the N. So first thing, we're going to move the N to the other side by dividing it away. So we have PV over N equals RT. And now we have to move the P over to this side, and let's divide away the P. And there we have volume over moles equals RT over P. Okay, so once again, we're just comparing volume and moles. So these are all remaining constant. So our official formula for Avogadro's law is V1 over N1 equals V2 over N2. Very, very similar to Charles' law. A quick hint, when they're on opposite sides, they're always going to form a fraction. If you're comparing things on the same side, they're not going to form a fraction. They're just going to be multiplied. If you can remember that, there are quick ways to get to these formulas. All right, I have 2 examples for you, so let's check them out. Just like the other days, here is our first one. All right, so let's start off with reading it. A 2.55 liter balloon with 3.5 moles CO2 began leaking. Once it was sealed, the new volume was 1.93 liters. How many moles CO2 are now in the balloon? So we have our V1, our N1, V2, N2. Volume 1 is 2.55 liters, and N1 is 3.5 moles. So it began leaking. These were the initial amounts, the starting amounts. Once it began leaking, the volume decreased to 1.93 liters. And now this is what we're trying to find. How many moles will that be? Well, let's plug it right into our formula. 2.55 liters over 3.5 moles equals 1.93 liters over N2. And this is, once again, a simple proportion, cross multiply and divide. Let me grab my calculator. Where's my calculator? There it is. All right, so 3.5 moles times 1.93 liters is 6.755 equals 2.55 times N2 is just 2.55 N2. All right, so now take the 6.755. Let's divide the 2.55. And I'm getting 2.65 moles. So N2 equals 2.65 moles. So you just have to identify the values, plug them in. The math itself is not difficult here. It is helpful to always write down these variables and make sure you identify them. I would keep doing this step. It's very, very helpful. All right, let's check out the last example here. You add 3.13 moles of argon to a balloon that already has 2.51 moles of argon and takes up 5.29 liters. What is the new volume? So V1, N1, V2, N2. So this is adding. So this is the second scenario. So let's look. It already has 2.51 moles and takes up 5.29 liters. So those are the initial conditions, the starting amount. Then we're adding 3.13 moles. So this isn't 3.13. We already started with this. We're adding 3.13 more. So 2.51 plus 3.13 is the new amount of moles is 5.64. So that one's just a little bit tricky, but if you read it, it's, just take your time and don't rush through it. Anyhow, now that we see the, now that we see what we're dealing with, let's use our formula again. V1 over N1 equals V2 over N2. So that is going to be, let's see here, 5.29 liters over 2.51 moles equals V2 over 5.64 moles. Cross multiply. So 5.29 times 5.64. And I'm getting 29.8356. Equals 2.51 times V2 is just 2.51 times V2. To get V2, we divide out the 2.51, and we're going to get V2 to equal 11.9 liters. Remember, the units here were liters, so this volume is also going to be in liters. Moles, moles. So make sure you're using units and stick with that. If you were able to do the last 2 days worth of work, I can't imagine you're going to have any difficulty with this one. Remember, if you are stuck, I am doing these online sessions, so please log in and ask me some questions. All right, complete the 3 questions on Schoology, turn them in, and then you are done for the week. If you have any questions, let me know. Have a great day.